Human beings use a numbering system called denary. There are 10 individual digits available in this system, from 0 to 9. For any numbers larger than 9, we simply need to take more than one of those digits and combine them in a single number. One of the reasons that human beings adopted this system was the fact that we had 10 fingers. Working with 10 individual digits was well suited to our nature. In a similar way, binary numbers are suited to the nature of a computer.
In binary, there are only two available digits, 0 and 1. As with denary, we can create larger numbers by using more than one digit at a time. There are several ways in which computers are ideally suited to work with this numbering system. A circuit can be either open or closed. A magnetic particle on a hard disk can be either north or south aligned. A location on an optical disk can be left blank or burned with a laser.
A computer's processor works by processing incoming binary signals and generating new ones. This system works because those signals are, at any time, turned on to represent a value of 1 or off for 0. If the inputs and outputs could represent more values, perhaps by varying the voltage, the components of the processor would need to be more sensitive, more expensive, and considerably slower. Actually, some input pins of some processors can accept and interpret varying voltages, but those signals are converted to binary as soon as they enter the processor.
So, binary exists because it can be easily stored and processed using a computer's various components. What about hexadecimal? In the hexadecimal system, there are 16 possible digits, which are the numerals 0 to 9, as well as the letters A to F. If denary is best suited to humans and binary is best suited to computers, what is the purpose of hexadecimal?
Hexadecimal is intended to be read by humans when they're performing a set of specific actions on a computer. In some work areas, particularly in network management, binary numbers are used a lot. The IP address used to uniquely identify your computer online is made up of 32 binary numbers. But binary numbers this long are easy to misread, so hexadecimal is used as a shorthand, human-friendly translation for a binary number.
4 binary digits can always be represented using a single hexadecimal digit. Just as there are 16 possible values for a hexadecimal digit, there are 16 possible combinations available for a 4-digit binary number. 4 zeros in binary translate to a single 0 in hexadecimal. 4 ones in binary translate to the hexadecimal digit F, which is the denary equivalent of 15. This means that our 32-bit binary IP address can be represented using 8 hexadecimal characters. This is then much less likely to be misread by a computer engineer.